I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I provide tutorials on TikZ and PGF plots, which are tools for creating graphics in LaTeX that compile right along with your document. I've been using these tools for a long time in my research papers, so I understand your frustrations. This is one of a sequence of videos where I'm covering the contents of my book, Unlocking LaTeX Graphics, linked in the show notes. If you like this channel, please subscribe, post questions, and share with your friends and colleagues. Today's topic is TikZ relative coordinates, which allow you to set a first coordinate and then make adjustments just from that, so you can shift your image around very easily or make copies very easily. I'll talk about the difference between plus and plus plus, as well as the turn command. I'm assuming you're already a little bit familiar with TikZ. If not, please go back and watch the earlier videos linked in the show notes. As usual, we'll be creating our LaTeX document at overleaf.com. So we'll go ahead and start a new project here. I will start with a blank project. I will name it Relative Coordinates in TikZ LaTeX Graphics. And then we'll go ahead and get set up here. I'm going to get rid of the package they have and set up things by using also TikZ. We really need that package. That's the most important one. And then I use Parskip and Full Page just because they make the layout a little bit nicer. And then we're all set up to get started. I'll go ahead and close this left panel and I'll enlarge the right side so that we can see things as we get cooking with our graphics. Okay, let's get started talking about relative coordinates. I already have a little segment of code here saved, so we'll go ahead and compile that. And this creates a triangle, a red triangle. We start at 1, 0, go to 2, 1, go to 0, 2, and cycle back. Let's see what happens when we change that code just a little bit. I'm gonna draw the first part of that line, and then I'll draw it in dotted and brown just to differentiate. We'll start at the same point, and then we'll put a plus plus in front of the 2, 1 and see what happens. This 2, 1 is relative to 1, 0. So that means we add it to 1, 0, and so we end up at the point 3, 1. We can do the same thing again with the next point. And we're gonna put a plus plus 0, 2, and we'll see what happens when we do that. That is relative to the point we were just at, 3, 1. Now we add 0, 2, and we're at 3, 3. And then we can cycle back and close the triangle as before. So each time we use plus plus, we are adding relative to the reference point and updating the reference point. So this was our first reference point. After the first plus plus, this became our reference point. And then after the next plus plus, this became our reference point. The last one actually doesn't really matter whether it's plus or plus plus because there's nothing coming afterwards. So we can do the plus instead. And so let's see what happens when we do that. Let me go ahead and add a line with just pluses instead of plus pluses, and let's see what's happened. So the first segment is the same. We do 1, 0 plus 2, 1, and we come to the same point, 3, 1. But now we have not updated the reference point when we just use plus. So our reference point is still 1, 0. And so when we add 0, 2, we go to the point 1, 2 because we're adding it to 1, 0. And so our second point is different. And then we cycle back as before. Now to understand the benefits of using relative points, I'm going to show you an example here. Here I have a picture of 2 diamonds using explicit reference points. So I have first a cyan point that starts at 0, 1, goes to 1, 2, 2, 1, 1, 0, and then cycles back. And then to do an orange point, an orange diamond just shifted up by 1, I have to recalculate all the points. I have to calculate 0, 2, 1, 3, 2, 2, 1, 1, and then cycle back. So what if I want to avoid doing that? Well, let's see how we can do it using just the plus command. If we do it with just the plus, the picture looks the same, but what have we changed under the hood? So we have 0, 1 as our reference point, then we do plus 1, 1. It takes us to this right corner. We're still doing with respect to this reference point, so our next point is plus 0, 2. And then again, with respect to the 0, 1 reference point, we do plus minus 1, 1, and then we cycle to finish out the picture. Now, if I want to repeat that in orange, I actually can just copy this line here and change just the first point and of course the color. And now I have another diamond without a lot of extra work because I've used relative points. Or if I just decided I wanted that picture in a different place, it's now very easy to use it since I've used relative points. We can also do the same thing using ++, and it's just a matter of taste in this case. It doesn't really matter which one you use, but when we use ++, we can get the same picture, but now our coordinates are just a little bit different because we're updating the reference point after each step. So we go ++ to come here to 1, 1, and we've updated the reference point. Then we go -1, 1 to get to the next point, then -1, -1 to the next point, and cycle back. You may remember from our first video that TikZ supports Cartesian coordinates and also polar coordinates, where you give an angle, colon, and a length. We can use that in the context of relative turns. So let me give you a little example here. Compile this. So the idea of a relative turn is you have to start off with a line segment. So here we have a segment from the point 1, 0 to 2, 0 using the ++ command. And then we're going to make a turn relative to this line segment of 60 degrees, which means if we extend this line segment straight and then go up 60 degrees, that's how we compute our angle. And then we go a distance of 1. Now, this relative turn works even if your line segment is not flat. So that's the nice, useful thing about it. So if we did another little segment of code here, where our line segment instead went 1, 0 to ++ 0.7, 0.7, and then we did a 60-degree turn. That turn is relative to the line emanating here. And then we go up 60 degrees and we go a distance of 1. So that's the idea of relative turns. So we can have an example where we're going to do a stop sign. So first I'm going to give it to you using just relative points, and then I'll show you how to do it with relative turns. So let's compile this little bit of code I've put here. So we've created here a 2x2 grid just for reference. And then we're going to start with respect to the point 1, 1 in the center. And then we're going to do a move to operation. So there's no dash dash there to the point that is relative to that is at 22.5 degrees and a distance of 1 from the center point. So that takes us right here. Then we're going to go 45 degrees to the point 67.5, a distance of 1. And then we're going to keep going in intervals of 45 degrees, drawing around the outside until we get all the way to 337.5, a distance 1 from the center. And then we're going to close it up with a cycle. And so we just use plus here because we don't want to update the reference point. The reference point stays 1, 1 the whole time. And it's interestingly not even exactly in the figure. We're just drawing a circle around it. But we can do the same thing using turn. And let me show you how that works. So here's our code for that. Using turn, we still have to draw the first line segment. So this code is unchanged from the example we just did. But then after that first turn, we don't have to calculate all these intervals of 45 degrees. We can just do a turn of 45 degrees relative to our current line segment. And then the distance we go is 0.77. If you work out your trigonometry, that's the approximate length of each of these little lines. And so we are doing a bunch of turns until we get to the end and we can cycle back. So turns can be a nice way to move around your graphic. If you like these videos and you want more, please click like or subscribe. Thanks for watching.